file. Let's make a working copy of stat.c, and we'll paste this into our working project. And I'm going to go ahead and maximize here so that you can see the entire file. And you'll notice there on line 18, this symbol is giving me an error. If I comment this out and uncomment this other one that's supposed to work more like this Mac operating system, it still gives me an error. And both of them actually compile and work just fine without error. So it's Eclipse that's giving this error. It's having trouble parsing the headers to give me that particular symbol, but it does still work. Let's go ahead and bring this down to size. I'm just going to compile and run this so you can see what it does. And we'll take a look here. On line 7, we define a constant file name, and that's actually this particular C file. So we didn't have to have another file in this directory. And then on line 8, we define a variable of type struct stat. The struct stat is the more or less normalized, standardized structure that has information about files. And on most operating systems, it's got a huge number of fields, and a small subset of them are more or less standardized. And we're going to take a quick look at what those are here. At a minimum, the struct stat is supposed to have these fields, and I'm just going to tell you right off the bat that those last three, C time, M time, and A time, those seem to not be standardized in some versions, and those are some of the most important ones. Those are the ones that are going to tell you when your file has been modified, accessed, and in the case of C time, either created or changed depending on the interpretation. You basically got the size of the file in bytes, and that one's pretty constant. The inode number only applies to file systems that have inodes. Keep in mind that a lot of this stuff in the standard C library was based on computers using Unix or a Unix-like operating system, or at least a Unix-like file system. And back in the days when C was first defined, of course, it was very tightly bound to Unix. And today it's not. So some of these things may not apply to your operating system. Inode is likely one of them. File mode is another one. This is whether it's read, write, execute, or what have you. And again, that's a Unix-ish concept. Number of hard links, likewise, owner and group. Creation time, modification time, and access time, those ought to be more or less universal, and for some reason they're not. And part of that has to do with the fact that the Unix time structures that these are supposed to return are not always compatible with the file system itself. So a lot of this stuff is very variable, and depending on your target operating system, you may have to work with this a little bit. So in line 10, we call stat, and stat returns an integer, and it's either 0 for success or not 0 for failure. And if it fails, then here I put out a P error. I'll go ahead and minimize this here so you can see the rest of that line. And so I take the results of this fstat, and stat takes two arguments, the file name and a pointer to the struct stat, which in this case is my fstat variable. And it will fill in that fstat variable that you point at. And so here I'm using fprintf to print out to your standard out. And I've got the file name in the first argument, and then the user ID, the group ID, and the size of the file. And again, on your operating system, especially if you're on Windows, you may not get anything in UID and GID, but you should get the size of the file okay. Now, the file modification time is in the number of seconds since midnight, January 1st, 1970, UTC. So we use GM time and stirf time to parse that out. And you'll notice I'm getting that error of the STM time variable not being recognized by Eclipse, but you'll also notice that it compiles and runs just fine. So sometimes we run into that with Eclipse. And I'm using stirf time to format the last modified time, and there we have it. So here's the function signature for stat. It returns an int, which is 0 for success and not 0 for not success. It takes a pointer to a file name and a pointer to a struct stat, and it will put the results in that struct stat through that pointer. So let's delete our working file.